Last year, for the first time, Villanova developed a boat that was dependable and stable, and this left our team this year in a very unique position in that even though we are somewhat brand new team, we can focus on actually figuring out how to accomplish each of the tasks rather than worrying about what went wrong with the boat. The goals of this year's team was to update a lot of the mechanical systems that included redesigning the robotic arm, redesigning the Land Rover, and swapping out the water cannon for Nerf cannon. We also wanted to focus on cleaning up the code. Last year we had some issues with buoy navigation getting mixed up with the extreme sunlight.
One of the new things we're attempting this year is the Catch the Ball challenge. In order to do this, we built a small rover that will disembark from our boat in a garage that we also built. The rover will use an ultrasonic sensor to detect the puck, and once it's close enough, it will close an arm that will hold on to the puck. The rover also has a color sensor in order to detect the edge, that way it doesn't fall off the platform. After the robot has caught the puck, it will retrace its steps in order to find its way back to its garage.
So this year, in order to improve the robustness of our color recognition, we are attempting to switch from the YCBCR color space, which is the luminosity and chrominance color space, to the hue, saturation, and lightness color space. The benefit of using the HSV color space is that we can use the hue channel to singularly identify a color without worrying about variance that can be caused by the brightness and the saturation. This allows for accurate color identification and the ability to keep track of a color even in different lighting conditions.
So one of the things that could really help our boat in terms of its functionality in the navigation course is being able to not only detect the buoys but also track them. The first thing that we really want to do in terms of getting tracking working is to get segmentation of the video in a more robust means. We want to work through a histogram method of back projection where we find the object, then we put a bounding box around it, and then we calculate a one-dimensional histogram of the hue. This we can then use to predict which pixels are likely to be the object.
We have the right team, the right gear, the right algorithms this year to really do well. And our students have been working very hard, they're excited, and we just cannot wait to get to the